We are going to describe the following differential equations, and how we're going to be doing this is by looking at their linearity, so if they're linear or nonlinear, if they're an ODE or a PDE, so ordinary differential equation or a partial differential equation, and also their actual order. So we've gone over all of these specifics in the playlist link below the like button, but we're gonna just summarize them here really quickly. So for this first one right here, is it a linear or nonlinear? Well, remember, for something to be linear, it has to be by itself, not contaminated by anything, it has to be a polynomial, and it can't be inside of anything. And this is for the dependent variable. Most of these rely on the dependent variable. So looking at this first one right here, we know that our dependent variable is going to be this y. And because it's this y, we look at all instances of it, so it's these three. Now, to determine its linearity, we need to see, again, if it's by itself. For all of these, they're all just being multiplied by constants. So that's a simple yes, it is linear. Now, is it an ODE or a PDE? Well, looking at our ODE or PDE, this is only going to be relevant for the parts that are being derived. Now, they're both derived over dx. So this is going to just be an ODE. It's not shared with anything else. Now, what's its order? Its highest order is going to be 2. So that's it for A. Now for B, is it linear or nonlinear? Our dependent here is going to be this y, so we're looking at these instances of it. Now notice our y is inside of this raised to the 4. So that's going to make it a nonlinear. Now is an ODE or PDE? Well, y is being derived twice, and it's over dx both times. So since it's being derived with respects to only d of x, this is an ODE. And its order is going to be 3, because the highest here is 3, and this one is 1. For C, we have a dependent variable of z, so it's going to occur here and here. Now, is this linear or nonlinear? Well, it is being derived with respects to dx and only dx. So for this one, it is going to be linear. PDE or ODE? Well, similar reasoning. This is an ODE and its highest order is 2. For this next one, it's a little bit tricky, right? Like we have y right here and right here. Now, these are the dependent variables, but this breaks our linearity because notice our y is inside of a square and it's inside of a square root. So this one is super nonlinear. Now, what about the ODE or PDE? Well, for this one, I kind of spoiled it. It is an ODE, and that's just because our dependent variable is over our independent variable, which is x by itself, and the highest order is this first part, which is going to be 2. For the next one, our dependent variable is y. Now, that occurs here, and on top of here as well. It is going to be nonlinear because it's inside of our cosine. Now, looking at the ODE or PDE, we only look at the part that's being derived, and since it's only being derived once, we know that this guy is for sure an ODE, and the order is 1. For F, linearity is going to be determined by our z right here. Now notice we have dx and dy on the bottom, and since it is being derived by two separate things that's shared across, this is going to make it still linear. This doesn't affect linearity at all. So z is just being derived. That's what we're looking for right here. Now it's not inside of anything, it's just by itself, it's not contaminated with anything. Now if z was inside of here, it would be nonlinear. Where this does affect us is in ODE or PDE. Since our z, the dependent variable, is being shared between dx and dy, this is actually going to make it a PDE, partial differential equation. Now the order for this is going to be 2, and let's move on to g now. So for g, our dependent variable is going to be y, it's all the way over here, all three of these. Now for this one, this passes our vibe check, right? This one does not though. This is a mess right here because we have our y prime times y. They're contaminating each other. We don't want that. We can't have them being multiplied together. If they were separate, it'd be fine, but that makes this a non-linear. Now for PDE versus ODE, we look at the part that's being derived, and since it's just derived to the first power, it is all good. It is an ODE, and the order here is 1. For this last one right here, we look at y, which is going to be the dependent variable. Now, is it nonlinear or linear? Well, for this one, it's going to be nonlinear for the same reason as g. This part right here, this is nonlinear. Is it an ODE or a PDE? Well, we look at the part that's being derived here, here, and here. And since it's being derived all with, we can assume with respect to dt, this is going to be an ODE, and the highest order here is going to be that second one in the parentheses. And that is how we would describe the following differential equations.